In this math counts preparation lesson, we're going to be focusing on problems where you have to use some intuition if you don't know what you're being asked for, and also recognizing a smaller problem. We're looking for the absolute difference between the mean and the median of the first 100 positive integers. This problem comes from the 2020 Math Counts School Sprint Round. It's number 21. So we're looking for the absolute difference between the mean and the median of the first 100 positive integers. So I'm going to underline the median, we're looking for the mean, and the first 100 positive integers. So that's basically from 1 to 100 inclusive. So from including 1 and 100, well, the median's not too hard to find. The mean is the main issue over here, the mean. And we could just we could start from 1, we can just add we know how to find the mean, we just take the sum of all the elements in this set, and then we just divide by the number of elements. So in this case, we're dividing by 100. And then we have this scary addition, which it's not really hard to add, but there are a lot of integers we need to add. Adding them would take forever. So instead, we're going to explore summations. And it's important that you understand summations because this leads to arithmetic series, and arithmetic sequences. So we're looking for the absolute difference between the mean and the median of the first 100 positive integers. I'm going to get rid of whatever's the easiest part of the problem first, since I don't make any mistakes there. We're looking for the median. Now, when I think of the median, the middle digits, two middle numbers, and we have 100 positive integers. 100 is an even number, so we have an even number of elements. That means we're looking for 2 integers that are in the middle, and then we have an equal number of digits on both sides. So before I just dive right in, I know that it's either 49 and 50, or I'm guessing it could be 50 and 51. Let's try 49 and 50. So if I try 49 and I try 50, well, 49 and 50, we're going to check how many integers. I'm going to circle this, and we're going to create some lines. All right, over here, essentially we have 1, and this 1 goes all the way up to this 48. Right, so we have a 1, and this 1 goes all the way up to the 48, right? And now over here, to find this is just 100 minus 50, which gives us 50 over here, and over here we have, well, 48 minus the 1 gives me a 47, plus 1 is a 48. We have 48 over here, and 50 over here, so it can't be this one. We're going to test 50 and 51. If I stick 50 and 51 into here, so if we stick 50 and we stick 51 into here, let's see what we get. So 50 and 51. So I know that this is just 149, which is 49 elements, and over here I have 51 to 100. 100 minus 51 is 49. Since 100 minus 50 is 50, and we go one more, so it's 49. These two numbers form our median. And now to find the median of we have the 2 most middle elements, we just take the average. So 50 plus 51, that's 101, and then we divide by 2. So now we have 101 divided by 2. And I know I'm going to have a 50, and I'm going to be left over the remainder of 1. So I have 50.5. So we already have part of the answer. Let's remove our work for the median part. We already have part of our answer. We have the median, which I'm going to express as a decimal, since it's going to be easier to subtract. We want the absolute difference. And now we want the mean. Now the mean, well, if you know summations, it's going to take, like, what, 30 seconds? Or 1 minute at max. Now the median is 50.5. We want to compute the sum of consecutive natural numbers from 1 to 100, inclusive. That's 1 plus 2 plus 3 plus 4 plus 5, all the way to 100. Now, let's set, we always like setting things to expressions. Let's set, this is a great example of an arithmetic series, but let's set this x is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6. And this goes all the way until we reach 100. Now let's rewrite this sum. It's still x, but this time we're going to rewrite the sum. We're going to say 100 plus 99 plus 98 plus 97 plus 96 plus 95 plus 94, and this goes on and on and on until we go back to 1. Now, let's add these equations. If we add these equations, we have, this is 101, this is also 101, this is also 101, 101, these sums are all 101. So we know that 2x, this value, this sum of 2x is equal to, so if we have 2x over here, right? And now 2x, if we add these, each of these sums is 101. Now we have 100 values, so this is just 101 times 100, which is just, we just slap on 2 zeros, right? And then we divide by 2. Now, I'm not going to do the division now, I'm just going to check. Like, I see it might be 5,500 maybe, but 100 is going to give me an extra 0, so I'm going to use 5,050. And if I multiply this by 2, I'm going to get a 0, another 0, and I'm going to carry the 1, I'm going to get a 101. So this is the value of our sum. We want the mean. And we're going to find the mean by, we're going to divide it by the number of elements. The number of elements, that's just 100. So now we have this divided by 100, right? Now, I'm not going to rewrite the division thing. I already know that this goes into 505 5 times, right? And then we're left with a remainder, and it's going to have a 50. So I'm going to have a 0 over here, since 100 goes into 50 0 times. And then I have a remainder of 50, and this is a mixed number of 50 over 100, which is 50 and 1/2 is a mixed number. I'm not going to rewrite this as a decimal, it's 50.5. So we have the mean, 50.5. This was awfully convenient. We want the absolute difference. Now this absolute difference is nothing but 0. Now this summation thing, this sum we just computed, is a summation, right? And a summation is a special case of an arithmetic series, which we will explore in future videos. But a summation is basically the sum of the first n positive integers. For example, the sum of the first 4 positive integers, that will be 1 plus 2 plus 3 plus 4. Now we can also express summations using sigma notation, right? So essentially we can set sum n to 1, and usually doing summations, this is how we write any summation. We want to go up to like 4. So this is another way you can write summations, but you won't really be using sigma notation during math counts. You don't really need it until you reach like AMC 10, 12, etc. So 1 plus 2 plus 3 plus 4. Now, how do we compute this? We multiplied 100, the number of elements, times the consecutive number ahead of it. Let's see this in action. Let's do the same thing here. And we divide by 2. Let's do the same thing here. Let's do 4 times 5 is 20. 20 divided by 2 is 10. Let's see this sum. 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 1 is 10. We rewrote this as 4 times 4 plus 1 over 2. Interesting. Let's compute the summation from 1 to 10. And the same way here, we just multiply 10 by 11 and divide by 2. So this is just 10 times 11 is 110. Divided by 2 is just 55. Let's check the sum out. We know the 4 is 10. Well then, if that's 10, well then we add 10, and then we have 5 is 15, 6 brings us to 19, 7. We keep going, and eventually we'll reach this 55 out here. So this technique is a well-known technique for any summation. For the first n positive integers, we can use the formula. Our summation s can be denoted as n times n plus 1 all divided by 2. Now, I don't like memorizing stuff, so I recommend you just don't memorize this formula. Just know how it works. Reorder the sum. Find the quick array to compute in any arithmetic series. Just look at these terms. Look at 100 and look at 1. And look at 100 and look at 1 and look like 101 give a sum of 101. And we take 101 and 1 and we divide it by 2. We get this 50.5. And we multiply by the number of that. So there are a lot of ways we can do this. Find the average, first and last term. You're going to learn about this more in arithmetic series, but you don't need to memorize this formula over here. This formula is not needed in MATHCOUNTS. So that's the basics of summations, arithmetic series, mean, median, etc. And over here, we saw how that works.